Hello everyone, and thanks for being here. My name is Luca Bischetti and I'm a postdoctoral researcher at the University School for Advanced Studies, USP Pavia in Italy. And today I'm going to present you a talk titled Cracking Smiles, the Zygomaticus major response to different joke types. Smiles and laughter are salient aspects of humor, typically representing one possible outcome of its comprehension and appreciation. Smiles and laughter follow previous processing stages that includes the humor comprehension stage and the humor appreciation stage, as proposed in the three-component theory of humor by Chan. As a linguist, I previously mainly focused on the incongruity detection and incongruity resolution mechanisms within the humor comprehension stage. But in this study, I will specifically focus on the incongruity resolution mechanisms and their relationships with the humor expression stage. There is a vast literature on humor comprehension and appreciation investigating the brain-associated activity. This activity can be examined by means of recording of brain regions activation with the fMRI. An example is the paper of Chan and colleagues from 2012. In this paper, they showed the activation of specific areas for incongruity detection, incongruity resolution, and humor appreciation. In this figure, they showed the activation of the brain areas linked with the incongruity detection. And here on the right, they showed the activation of the brain areas linked with the incongruity resolution and humor appreciation. Humor processing can also be examined by means of recording of the electrical brain activity with EEG. An example is the paper of Canal and colleagues from 2019. In this paper, we showed a different pattern of activation for incongruity detection, incongruity resolution, and humor appreciation. Incongruity detection was indexed by an early negativity between 300 and 500 milliseconds. The incongruity resolution mechanisms were indexed by a positive effect, a positive going wave between 500 and 700 milliseconds, while humor appreciation stage was indexed by a later positivity up to 1 second. A different view on humor correlates can be provided by means of the electromyography, that is the recording of the electrical activity produced by skeletal muscles. This technique is particularly suited for studying the humor expression stage because it is a measure of humor-evoked emotional reaction if tested over facial muscles, such as the zygomaticus major or the smiling muscle. Notably, there is a dearth of studies using this technique in the humor domain, and this is especially true for verbal humor. To the best of our knowledge, there are only 2 studies on this topic. The first study is a study of Fiacconi and Owen from 2015. They tested jokes versus non-jokes, and they found greater activations for jokes over the zygomaticus major, starting from about 800 milliseconds. The other study is a study of Morisot and colleagues from 2016. They tested jokes based on group affiliation, and they found greater activation of the zygomaticus major for in-group jokes, starting from about 4,000 milliseconds. However, these studies fostered limited exchanges with the theoretical domains, such as linguistic pragmatic approaches to jokes. Also, they rarely investigated specific or different type of jokes. And with specific type of jokes, I point to, for example, dark humor or COVID-19 humor or jokes, and with specific or different type of joke, or the comparison between type of joke, I point to a comparison between nonsense and canned jokes. From the linguistic point of view, joke comprehension and joke variability are described in different frameworks, but particular attention to the different joke feature is included in the general theory of verbal humor. Among these features, there are the sources of the incongruity or script opposition and the resolution mechanisms or logical mechanisms. And I am particularly interested in them because logical mechanisms represent the pragmatic processes that allow the perceiver to understand different joke types based on specific inferential paths. And we also found support for the distinction included in this framework in the general theory of verbal humor, because different logical mechanisms shape the brain responses associated with incongruity resolution within the incongruity resolution time window that is between 500 and 700 milliseconds. In this study, we showed that logical joke triggered a greater positivity than mental jokes, and these can be accounted by the different logical mechanism involving the resolution of these two different types of jokes. In the present studies, we wanted to examine the response to these two joke types for logical jokes based on sound similarity and mental jokes involving false mental states attribution. And we compared them to non-humorous counterparts. We wanted to answer this question: are these differences, the differences highlighted in the EEG study, detectable also with the EMG? This was never investigated. The difference between more than one type of joke was never examined before. Our materials comprised 64 phonological jokes. Here an example: 2 university professors. Dear colleague, starting tomorrow, I'll leave my duty for a year and I'll move to Brazil. And the other: oh, I see, you take a sabbatical year to rest a bit. And this humorous ending was compared to a non-humorous one that reads, and the other: oh, I see, you take a sabbatical year to rest a bit. Our materials also included 60 mental jokes. Here an example that reads: 2 female friends talk about their youth while they're having a tea. One says, you know, my love story ended in a tragedy, and continues, yes, eventually I married him. And this ending was compared with a non-humorous one that reads and continues, yes, eventually I left him. These materials were based on a previous work where we included and we created the phonological and mental joke task with only 12 jokes. So this material were an expansion of previous material used in other studies. As shown in phonological jokes, the humorous condition was due to an incongruity arising from similar patterns of sound conveying different meanings, whereas in mental jokes, the humorous condition was due to an incongruity between belief and thoughts, because these thoughts were later disconfirmed. And these mental jokes are based more on theory of mind than phonological ones, and the processes involved can be deemed as the attribution of false belief. We hypothesized that jokes would trigger stronger EMG activation than non-humorous counterparts from about 800 milliseconds, in line with Fiacconi and Dongwen. And we also hypothesized that joke types would modulate the EMG response, with phonological jokes eliciting a faster and stronger EMG response than mental ones, due to the straightforwardness of comprehension as shown in our previous EEG study. We included 35 right-handed participants speaking Italian. The task was a simple reading task while we recorded the EMG over the right zygomaticus major muscle, according to von Boxer 2020 description. EMG raw data was pre-processed in line with Thompson and Collis 2016, and we segmented EMG raw data in epochs spanning from -2 seconds to +4 seconds around the target word onset. We low pass filter the raw EEG data with notch filter at 50 Hertz and its harmonics. We rectify the data, we demean them, and we correct them with a 1 second baseline. The EMG activity was also time locked to target word onset and expressed as a percentage of change from baseline activity, average in 10 consecutive 400 millisecond time windows. We analyzed our data in this way. Funniness ratings and log transformed single try EMG data were analyzed with linear mix models in R. We included cross-random effects for participants and item, And we allowed within participants slope adjustments for condition and type and their interaction, and within item slope adjustment for condition only. After pre-processing, we also excluded one subject because it showed too much artifacts. We tested how funny were our jokes compared to the non-humorous counterparts, and we found that jokes were funnier than non-humorous counterparts, but there was no difference in how funny people perceived and rated our stimuli. With respect to the EMG, we found a significant effect of condition, of time window, the interaction of condition by type, the interaction of condition by windows, and also marginal two-way interaction between condition type and time window. And exploring this two-way interaction, we found significant changes for phonological jokes from the 800 to 1200 time window. And this is the blue line on the top. By decomposing this interaction, we also find a significant changes for mental jokes starting from the 1200 to 1600 millisecond time window. And this is the golden line. And also we found stronger EMG activity for phonological jokes between 1200 and 2400 milliseconds. And this is depicted by the dot-dashed black line in this plot. So we can see overall the difference between humor depicted by these solid colored lines and the non-humorous counterparts here represented with the grayish lines. So overall, jokes triggered a stronger muscle activity from about 800 milliseconds as hypothesized and compatible with Fiacconi and Owen results. But also there was a different time course of EMG changes because phonological jokes triggered a greater EMG response 400 milliseconds earlier than mental ones. And this can possibly signal that a faster overt expression of mirth, so a smile, may accompany more conclusive resolution mechanism, resonating with a faster reaction to the brain activity elicited by wordplays following the EEG results in our previous work. And also mental joke might be less prone to trigger these physical reactions soon after the target would onset because the effects started later at about 1200 milliseconds. In conclusion, we found this difference between EMG activation between phonological and mental jokes. We provided novel evidence on the role of logical mechanism on the physical bodily responses to verbal humor and linked these responses to the conclusion of the inferential path supporting joke comprehension. And this was also beyond the neuropsychological correlates, confirming both our previous studies and providing novel evidence on the distinction between logical mechanism theorized in the general theory of verbal humor. The take-home message is that the way we get a joke does influence how long it takes and how much we smile at it. I want to thank all the co-authors of this work, Professor Bambini and Dr. Paola Carano from the University School for Advanced Studies, USP Pavia, Dr. Chiara Bertini and Irene Ricci of the Scuola Normale Superiore, and Professor Lecce from the University of Pavia. If you have any question, please ask me, drop me an email, or contact me on Twitter. Thank you very much.